the ratios of 4:1 are moving with the equal linear momentum. The ratio of their masses is, now you see, two bodies with kinetic energies in the ratio 4:1. Okay, then these two bodies are moving with the same linear momentum, means the linear momentum value is constant. We have to find the ratio of their masses. What is the relation between linear momentum, kinetic energy and masses? So we can write here kinetic energy equal to P square by 2m. What is the kinetic energy? What is the formula? Kinetic energy equal to P square by 2m. Here which one is constant? Linear momentum is constant. Which one is constant?
Linear momentum.
P is constant. This kinetic energy depends on only mass. Kinetic energy depends on only mass. Kinetic energy is inversely proportional to mass. Right? If kinetic energy increases, mass value decreases. Which one? Who will run fast? Bigger mass having person or smaller person? Smaller mass having person. Smaller person. If mass is less, kinetic energy is more. That means, what is the relation between these two?
Inversely proportional.
Inversely proportional, right? If kinetic energy increases, mass decreases. Inversely proportional means this we can write as Ke1 by Ke2 is equal to M2 by M1. It's inversely proportional. You make it reciprocal. Inversely proportional means Ke1 by Ke2 which is equal to M2 by M1. Okay, so what is the Ke1 ratio they given here? The given values of Ke1 is to Ke2. How much they given? 1:4 or 4:1? 4:1. So this we can write as 4 by 1 which is equal to M2 by M1. But we required M1 by M2, right? We required M1 by M2. So M1 by M2 equal to, so just you make it reciprocal, this 1 by 4. So what is the answer? Answer is D, 1:4. So here linear momentum is constant. You need not to consider the P value. Okay. If mass values are constant, you need not to take the mass value. If kinetic energies are constant, you need not to take the kinetic energy. Okay. Then get the relation between the other two terms. Right. Here kinetic energy is inversely proportional to mass. So which one is the right answer here? D, 1:4. If F equal to 60I 15J minus 3K, 60I plus 15J minus 3K, and velocity vector equal to 2I minus 4J plus 5K meter per second, then instantaneous power is, so what is the formula to find out the instantaneous power? So power equal to F dot V. This is a dot product of force and velocity vector. Okay, so what is the force vector? 60I plus 15J minus 3K. So dot 2I minus 4J plus 5K. Okay, now you see, now we have to multiply with 60 with 2. 60 into 2 is how much? 120. I with I you multiply. What is the J term here? 15. Here J term is minus 4. 15 into minus 4 is?
Minus 60.
Minus 60. Here what is the K term? Minus 3. Here what is the K term? 5. Minus 3 into 5 is?
Minus 15.
Minus 15. 120 minus 60 is?
60.
60. 60 minus 15 is?
45.
45. So what is the answer? 45 watt. 45 watt is the right answer. So answer is B. Okay. A child is sitting on a swing. Its minimum and maximum heights from the ground is 0.75 and 2 meter respectively. Its maximum speed will be, let us say, this is the swing. Everyone please have a look at it. So this is the swing, right? Let us assume this is the swing, right? So when you move up to the position point A, at point A, it's the highest position. So where you have the potential energy is more, right? So where you have the potential energy is more. So when you move like this in swing, so here let us assume this is a point A. This is a point A, right? So this is a point. So when you move from here to A point to B point, let us say this is a B point. Okay, this is a B point. Okay, this is a B point. This is A point and this is a B point. So when you move like this, so let us say this is a O point. Okay, this is the equilibrium position is O point. Let us say this is a ground. Okay, this is a ground. What is the height from the ground? Already they given. What is the maximum height from the ground?
2 meter.
Yeah, maximum height from the ground is how much?
2
2
meter.
meter. This height is how much? This height. This height from the ground. How much it is? 2 meter. Okay. So what is the minimum height from the ground? 0.75 meter. Okay. Already you know that where will you get more potential energy? When you move in a position where the height is more, okay, where you have the more potential energy. Okay, when swing moves towards in O direction, right, in equilibrium position, when it is reaches to the equilibrium position, height decreases, velocity increases. That means potential energy decreases, kinetic energy increases. Where you have the more potential energy at position A. Where you have the minimum potential energy at position O. Okay. The change in potential energy, which is equal to gain in kinetic energy, as per law of conservation of energy. Okay. The maximum drop in potential energy is equal to the maximum gain in the kinetic energy. Let us assume that. So here I will take one more situation. Let us say in vertically thrown upward ball. Okay, so this is a position A. Let us say this is a position B, and this is a position C. This is a ground. Okay, listen. Just assume that this is the highest point. Highest position means a highest point where the height is more. So the ball has maximum potential energy where the ball is at the highest position. Let us assume the highest point, the potential energy is in how much?
100
100 joules. When it is moving down, when ball is moving down, the height decreases. That means the potential energy also decreases. But the sum of potential energy plus kinetic energy always remains constant and same value. So what is the potential energy value when it is at the highest point? 100 joules. When this ball comes from A to B, let us assume that the potential energy dropped to 40 joules. How much it is?
40 joules.
40 joules. Let us assume that 40 joules. Okay, let us assume. Then kinetic energy increases to 60 joules. Very good. The potential energy when it is this is the potential energy. Then kinetic energy increases to 60 joules. Then how will you get this 60? When you do this 100 minus 40, then this is equal to the 60 joules. Means the maximum drop in the potential energy is equal to the maximum gain in the kinetic energy. Means highest position means where we have the maximum potential energy. Here we have the minimum potential energy. The change in potential energy, the maximum drop in this potential energy, which is equal to gain in kinetic energy. Okay, how much it is? 40 plus 60 always remains same. Here also you will get 100 only. Let us assume when potential energy did drop to 20 joules. Then kinetic energy increases to 20 plus 80. How will you get this highest point? How much it is? 100. At C point, how much it is? 20. 100 minus 20 is how much? 80. Which is equal to increase in the kinetic energy. 100 minus 20 equal to 8. Then 20 plus 80 you do. You will get here also 100. But that value is always remains constant. But here what is happening? The potential energy decreases with the height and the kinetic energy increases with the velocity. When you add these potential energy plus kinetic energy, the value is always remains same. That is constant according to law of conservation of energy, right? So the same concept you have to apply here also. Okay, now you see then how to apply this concept here. When the swing moves from the point A to point O, there is a change in the potential energy. Let us assume that highest point. What is the highest point from the ground here given?
2 meter.
2 meter. When it is coming to the O point, what is the highest point from the ground? 0.75 meter. So where will you get the maximum velocity? At O point. Where will you get the maximum velocity? Okay, when swing moves from the maximum height to minimum height, whenever the swing comes to O, where you will get the more velocity. Okay, in this question you have to find the maximum speed. Where will you get the maximum speed? At the position O, right? So now, same concept here also you have to apply. The maximum drop in the potential energy, maximum drop in potential energy which is equal to maximum gain in kinetic energy. Then how do you know this maximum drop in potential energy? At the highest position, let us assume this is the height h, capital H. This is the small h. Okay, the change in the potential energy between the two heights, from the ground to the A point, from the ground to the O point. Okay, the change in potential energy you have to find out. So yeah, take the formula here. What is the potential energy formula? mgh. What is the potential energy formula?
MGH.
mgh. So mgh. So this will give the maximum potential energy at A position. Potential energy at the point A minus minimum potential energy. Where will you get? At low height. Okay, this decrease in the potential energy is equal to increase in the kinetic energy. What is the kinetic energy value?
Half mv square.
Very good, half mv square. Okay, now you just substitute the values here. Mg you take common from these two terms, so mg you take common, then what is that? H minus h equal to half mv square. Both side mm get
Cancel.
what is the capital H value we have assumed here? 2 meter minus small h value is 0.75. Very good. Which is equal to half
V square.
Okay. 2 minus 0.75 is
1.25.
okay. So v square by 2. Okay. 10 into 1.25 is 12.5 v square by 2. By 2 when you take it this side into 2. So then this we can write as v square into 2 into 12.5. 12.5 is into 2.
25.
V square equal to 25. Then v equal to square root of 25. And v value is how much? 5 meter per second. Then our answer is
Option B.
very nice. Option B. When a long spring is stretched by 2 centimeter, its potential energy is U. If the spring is stretched by 10 centimeter, then you find the potential energy is how much. Okay. So what is the relationship between the potential energy and its moving distance? Okay. So this is U is directly proportional to x square. Okay. What is the formula? U equal to minus k x square, and this is a formula for the potential energy stored in a spring. Okay, if distance moved increases, the potential energy stored in the spring also increases. Means the potential energy U is directly proportional to x square. Yes or no? Is it directly proportional or inversely proportional? If you press more, then the potential energy stored also more. If you press the spring less, the potential energy stored also less. Okay, and this is directly proportional, but is u directly proportional to distance square, right? X square. Okay, then how will you derive the relation between the u and x? Here we have the two incidents, right? When x is at 2 centimeter, they given that potential energy value is u. Okay, when you compress the spring up to 10 centimeter, so what is the potential energy stored in the same spring? Okay, so to derive this, so we have the formula u1 by u2 equal to x1 square by x2 square. Okay, use this formula. So what is the u1? u1 is equal to u. What is the potential energy when it is at a distance 2 centimeters, sorry. When x1 equal to 2 centimeter, potential energy stored is u. When x2 is increases to 10 centimeter, then potential energy stored is how much? Okay, then you this please replace these values, please substitute these values in the given equation, then you will get this relation. Okay, all of you please do this. So what is the u1 value? What is the u1 value? That is u2 value we need to find out. X1, what is x1 value? 2 centimeters. So 2 square is there, right? 2 square. What is the x2 value? 10 square is there. So 2 square is 4, 10 square is 100. Then 4 how many times 100 it is? 25 times. So u by 1 by 25. Then u equal to do you do the cross multiplication now? 1 by 25. You do the cross multiplication like this. Okay. Then this we can write as u2 equal to 25 times of u. Okay. So this is your answer. ut equal to 25u. And when you compress the spring up to the 10 centimeter distance, the potential energy stored increases to how many times when compared with the initial time? 25 times increases. How many times increases? 25 times that energy value increases. Okay. A mass of 0.5 kg moving with a speed of 1.5 meter per second on a horizontal smooth surface collides with a nearly weightless spring of force constant K equal to 50 Newton per meter. The maximum compression of the spring would be how much? Okay, so this question given in NEET 2004. Now, what is the mass of the ball they given? Mass of the ball they given as
0.5 kg.
0.5 kg. How much it is? 0.5 kg. Mass of the ball is how much? 0.5 kg. Okay, and it is moving with the velocity 1.5 meter per second. Okay, and the spring constant value they given here 50 Newton per meter, and we need to find the compression of the spring x value. How much? Then how do you get this? Now you see, whenever the ball moves with some speed, it gains some kinetic energy. Yes or no?
Yes, sir.
And this balls moves with some speed. So when this balls moves with some speed, it will gains. So it is moving with some energy, velocity. It has some mass. Because of this mass and velocity, it gains what? Kinetic energy. So with this energy, it collides one spring. It collides one spring. Because of this energy, okay, the spring is compressed to some extent, right? Some distance. And the maximum compression of the spring we need to find out. Then how do you get this? And the ball has which energy now? Already you know that. That is kinetic energy. Because of this kinetic energy, here compression is taking place, right? Means the kinetic energy of the ball is slowly converted into, yes, the energy required to compress the spring. Yes or no? The kinetic energy of the ball is slowly converted to energy required for the spring. Energy required to compress the spring. Energy required to compress the spring. Okay. Okay, already you know that. What is kinetic energy? Kinetic energy formula, please, everyone.
Half mv square.
Very nice. Kinetic energy formula is
Half
half mv square. So I am writing here. Kinetic energy formula is half mv square, right? So half mv square. Energy required to compress the spring. We have a
Half
formula.
kx square.
Very good. That is half kx square. Both side half of get cancel. What is the mass value we have here? 0.5. So 0.5 kg, and the velocity value is 1.5 into 1.5, and k value is 50 into x square. Okay. Now listen how to do this, how to solve this. Now you see, by 50 you take it this side. So here 1.5 is there. After point we have one digit. This we can write as 5 by 10. After point one digit, this we can write 15 by 10. After point one digit, we can write 15 by 10. Okay, this into 50 when you take it this side, so it will become by 50. Then this we can write as x square equal to so 5 into 15 into 15. Okay, so 10 into 10. Okay, you write like this 50 into 10 into 10 into 10. Okay, when you solve this, listen, everyone please. So 5 how many times it is? 10 times. Okay, 10 into 10, 100. So here also 100. Here also 15. Here also 15. Then x square equal to this much. Then x equal to root over 15 into 15 by 100 into 100. So 15 square. This we can get 15. This we can write 15 in 100 square. This we can write as 100. So what is the 15 by 100 values? So 0. How much it is? 15 meter. And so here that means the spring compressed up to 0.15 meter. The spring compressed up to how much distance?